Hello everyone, hopefully you're doing well. In this video, we're going to find the slope of the graph of the function at the given point. We're going to use the derivative feature of a graphing utility to confirm the result, but we're not gonna really reuse the graphing utility, but we're going to use derivative to find the slope of the graph. So one of the things you need to remember anytime you're looking for the slope, you need to find first the derivative of the functions. Because if you're looking at this derivative, I'm going to use the red. If you're looking at these functions right here, it looks like it's in the form u times v, so that's a product rule. And if you want to find the derivative of a product rule, you need to find the derivative of u and the derivative of v, and you multiply u prime v plus v prime u. So in these functions, let's say u is tangent x. So what is the derivative of tangent x? If you have the book Calculus 1 Lesson and Bruce Edward, you can go in chapter 2, section 2.4, section 4 in chapter 2. You would see the derivative of tangent x is secant square x. And if you set v equal cotangent x, so the derivative of cotangent is negative cosecant square x. Now, to find the slope, we need to find the derivative of that function first. Once we find the derivative, because these 2 points is the first one is x, the second one is y. If the function is in x coordinates, then we're going to plug the value of x in the derivative. Whatever we find would be the slope. So now what is the derivative of the function f? So derivative of f, derivative of f prime of x is, remember, we're going to use that formula, u prime v plus v prime u. First of all, we're going to take u prime is secant square x times v cotangent x plus v prime is negative cosecant square x times u, which is tangent x. Now, we see something you might remember studied in pre-calculus also. If I have, anytime I have secant, for example, I know secant is 1 over cosinus. Or if I have cosinus, I can replace it by 1 over secant. So secant x is 1 over cos, that's as an identity, and cosecant x is 1 over sine x. So when I see secant square x, I can rewrite it as 1 over cosinus square x times cotangent. What is cotangent in form of sinus and cosinus? Cotangent, you can replace cotangent x as cosinus x over sinus x. So this is the identity, trigonometric identity for cotangent in function of cosinus and sinus. So cotangent, we can rewrite it as cosinus x over sinus x. Now, plus minus give us negative, and we said that cosecant square x is 1 over sinus square x. Tangent as an identity, trigonometric identity in function of sinus and cosinus is sine over cos. Now, when I see this one, I can replace it by sinus x over cos x. All right. Now, because we have two different cosinus. We have cos square x, so we can simplify this cos with this cos, and we simplify one sine with one sine. So what we have left for the derivative of f is 1 over, because I cancel out one cos, so I have one left, sinus x, minus, I cancel out the sine in the top and cancel one at the bottom, so I have one left because I had cos sine x twice. Okay, what you see here, 1 over cos x sine x, and you can rewrite it if you want this way also. You can say it is f prime of x equal 1 over sine x cos x minus 1 over sine x cos x. So is that 1 minus 1 or 2 minus 2, 3 minus 3? So what is the derivative of x is simply 0. Now the questions was to find the slope. So the slope, usually we call the slope m, is f prime of 7, because you have the point 7. 7 is x and 1 is y, but because in that functions we don't have the y variable, we only have x, we're going to substitute x for 7, but there is no x because the derivative is 0, so the slope is simply 0. And this is the questions that we're asking you to find. I mean, you need, first of all, to find the derivative of the functions. And once you find the derivative of the functions, you plug the value of x in the derivatives. So what you'll find would be the slope of the graph of the functions at that given point. So one thing we don't do is to graph using a utility, a graphing utility, but you can either use a TI 83 or 84, 89 or 92 and just hit graph y and you plug these functions, and definitely you can see what type of graph you're gonna have for this protocol f of x equal tangent x times cotangent x. Hope you like this video. Don't forget to subscribe for more videos. Take care.